Hi, I'm Ms. Boong and I'm quite excited about today's topic, trigonometric ratios, because you see this in a lot of places, from aviation to marine biology to criminology. You even see it in music when you're looking at sound waves. So what does this topic mean? Well, in Greek words, it means to measure a triangle. So we're going to look at the angles and the sides of a triangle. First of all, let's learn the names of each of these sides. There's a right angle over here, and right across from that, so on the other side, not touching the right angle, so on the other side, this length is called the hypotenuse. A silly way to remember this is a bigger side, and hypotenuse sounds a little bit like hippopotamus, which is a pretty big animal. So hypotenuse. Hippopotamus has nothing to do with this topic, it's just a silly way to remember the word hypotenuse. What about the two other sides? Well, if the angle we're looking at is this one, and I'm using theta, the Greek letter theta here, this symbol, to represent the angle, then the neighboring or the adjacent to that angle is called adjacent. So adjacent means neighbor. And the opposite to that angle is opposite. What if we're talking about that angle at the top there? Well, the hypotenuse wouldn't change, it's still that one, but now the adjacent would be this side and the opposite would be over here. And instead of writing the whole word, we're going to summarize today by writing just H for hypotenuse, A for adjacent, and O for opposite. So again, that side is the H. If the angle is up here, then that will be A, and that therefore is O. And if the angle is at the bottom, then A is down here and O is over there. Let's have a look at these triangles. I will disappear and you can pause the video now and see if you can label them correctly. Unpause when you're ready to check. Okay, so that one's similar to this one we started with. So that side is our hypotenuse, adjacent is next to there, and opposite. For that one there, we have hypotenuse over here, and that's going to be the one next to the angle, adjacent, and that's going to be our opposite. For that triangle, we have the hypotenuse over this side now, because that's the right angle there. So H goes here, adjacent is over there, and opposite is there. Over here, the right angle there, so H is over there. So notice that we always start with H. Adjacent is over here, and opposite to the angle is there. That one, H is over there. That's adjacent, and that's opposite. Over here, right angle is here, so H is here, and A would be there, and O is there. And lastly, the right angle is up there, so H will be at the bottom here. The angle is over there, so adjacent will be over there, and O is there. Did you get them right? I hope you did. Let's have a look at some ratios this time. Here we have, let's say 3 centimeters and 3 centimeters. The ratio of an equilateral triangle will be 1. And we know that the angles of a triangle are 180, that's 90. So these two have to add up to 90. And because they're the same size, that one's going to be 45 degrees. Now what happens if we change the side of the triangle? So if it's a smaller size, well, the ratio of the two sides is still the same, 1, and the angle hasn't changed, it's still 45 degrees. So even if we made it bigger, 10 and 10, the angle would still be 45 degrees and the ratio will still be 1. So even if it's huge and it's a bajillion centimeters long and a bajillion centimeters wide, then the ratio would still be 1 and the angle will still be 45 degrees. Now this should ring a bell from similar triangles because they have the same ratios and same angles. Now bear with me with this part, it's going to be a bit tricky. Let's try draw some triangles with 30 degrees. Let's say one side is 3 centimeters, and of course I want it to be right angle because that's the triangles that we're working with. If I want it to be 30 degrees, then there's only one position that I can draw the third line. And that third line will be 6 centimeters. Again, the ratio would be 3/6 is a half. What if I would draw a line that was 10 centimeters? If I wanted to find a 30-degree angle in this triangle, it would be 20 centimeters. always 20 centimeters. I can't draw it any other way if it's the same angle. So now the ratio is a half. So you can see that when we're doing the ratio of the two sides, it's always going to give us the same ratio for the same angle. This is true from, we had a look at this from similar triangles, but today we're going to name these ratios. So remember the three sides of the triangle: hypotenuse, opposite, and adjacent. We can observe that when just now the opposite over hypotenuse gives us the same angle, we call this ratio the sine. And we abbreviate it with sine theta equals the ratio. Now we looked at O and H. Another pair of sides we can look at is A and H. And that's going to be the complement of sine. So complement of sine, cosine, and abbreviation for that is cos theta. And lastly, which two haven't we used? We haven't looked at O and A, and that's going to be the tangent of theta. Now tangent is abbreviated as tan theta. Now, tan or tangent is pretty awesome, but we don't have time to go through it today, but just trust me, it's pretty awesome. You might recall tangent as a line that just touches a circle, and you might notice O over A, O as in that height, A as in that length, or O as in the rise over A, the run. You might remember that from linear equation as being the gradient. So tangent's pretty cool, but we're not going to go through it today because it's too much. In summary, so sine theta, cos theta, tan theta. Sine theta is over H, cos theta is the ratio A over H, and tan theta is O over A. Pause the video and try to memorize it. A way to remember these trigonometric ratios is SOHCAHTOA. Can you see where I've obtained the SOHCAHTOA from? So sine, opposite hypotenuse, cos, adjacent hypotenuse, tan, O over A. So SOHCAHTOA. They don't mean anything, it's just an acronym to help us remember. SOHCAHTOA. Try saying it 10 times so it sticks. Write the equations for the sine, cosine, and tangent ratios. So let's have a look at this. First of all, what do we need to do? We need to label it. So that's the hypotenuse because it's across from the right angle. Now the angle's over here, so that's the adjacent. And lastly, the opposite. Now we have those three. We remember SOHCAHTOA. And we can write down sine theta is equal to, so O over H, 3 over 5. Cos theta is equal to A over H, so 4 over 5. And tan theta, or TOA, is O over A, 3 over 4. Let's do another example, this time different numbers, and instead of theta for the angle, we're going to use x. So remember, SOHCAHTOA. Remember it because I'm going to get rid of it in a second and not have it there for you this time. SOHCAHTOA. It's gone. It's in your head now. SOHCAHTOA. SOHCAHTOA. First step, label it. So hypotenuse is over here, next to the angle is here, opposite is over there. SOHCAHTOA. So sine, what is sine? So, S-O-H. So sine x is equal to 7 over 15. Cos x is equal to A-H, 8 over 15. And tan, TOA, so 7 over 8. I hope you got that. If not, rewind, pause it, try it again, and see if you can get it. Practice until you have memorized it. Most of the time you see triangles that look similar to this. So you have two sides and an angle, so not all three sides. And in that case, what are you going to use out of SOHCAHTOA? First of all, label it. We have H, adjacent, and opposite. We notice that we have the opposite and adjacent and not H. So then we think, out of SOHCAHTOA, which one has O and A? So that is tan. So we're going to use tan theta equals O over A. So tan x is equal to O, 7 over A, 11. So that is our trigonometric ratio. Now this time you try, pause the video and continue when you're ready. So step 1, label it. So again, 90 degrees is there, so that's H. Next to the angle is A. and on the other side is opposite. Then think O and H. What are we going to use? So katoa, we're going to use OH sine. So sine x is equal to OH, so 9 over 18. Be very careful, not HO, there's no how you maths, it's OH. What about this one? Pause the video again and then continue when you're ready. Step 1, you label it. So H, A, and O. Now this time we have A and H. So which one had A and H? It was cos. So cos 30, this time we have the angle. Cos 30 is equal to A, well A is X and H is 5. That's pretty much it for the introduction of trigonometric ratios. So what are the steps? Step 1, label it. And then step 2, use one of these. So katoa. So definitely memorize them. I will test you when I see you. That's it from me today. I'll see you next time.